Hey, let's try one other question. This is number 26 on the AP packet. I'll try to get A and B answered in this video. So we have a curve xy squared minus x cubed y equal to 6. Part A, find all points on the curve whose x coordinate is 1 and write an equation for the tangent line at each of these points. So the first thing is that the x coordinate has to be 1. If you want the equation of the tangent line, remember you need a point and a slope. So right now we are concentrating on finding the point, and what we know so far is that x has to be 1. That's why the first part says find all the points where x is 1, and we don't know what the y would be. So how do we find all the points where x is 1? You go to the original equation and you let x be 1. So we have, for some reason, I've noticed that my writing is not coming out in the right positions at first in the videos. So I'll try to fix that on this video, but I'm not sure that it'll happen. Anyway, I'm going to let x be 1. So we'll have 1 times y squared minus 1 cubed times y is equal to 6. I'm just going to the original equation and letting x be 1. And so that'll give us y squared minus 1 cubed is 1 times y equal to 6. And it looks like a quadratic, and quadratics are best when they're set equal to 0. So y squared minus y minus 6 is equal to 0. And the next thing I'll try is factoring it out, because it looks like it's factorable. So if we factor that out, we'll have y minus 3 and y plus 2 equal to 0. And then that would be y equal to 3 and y equal to negative 2. Now, it says find all the points where the x coordinate is 1. So we plugged in a 1 and we got these two y's. That means we have 2 points. We have the point 1, 3, because x was 1. And then we also have the point 1, negative 2. And so you're thinking, this is not a function. Yeah, it's not a function. But we can still find tangent lines, and we can still find equations of the tangent lines. So we have 2 points. Now, the next thing we need is the slope. Remember, we need a point and a slope. And for the slope, we need to take the derivative of this function up here. So that'll be a product rule for the first piece. So that's the first x times the derivative of the second 2y prime plus the second y squared times the derivative of the first 1, and then minus, and I'm going to open parentheses, and this is important. Remember, there's 2 ways of looking at it. You can say it's negative x cubed and then keep track of negative x cubed, but I think the best way to do it is just take that negative, bring it down here, and then open parentheses, and then do a product rule with positive x cubed and positive y, and distribute the negative at the end. So that's what I'm going to try and do. So minus another product rule, the first x cubed times the derivative of the second y prime plus the second y times the derivative of the first 3x squared. And then all that equal to the derivative of 6, 0. Now we have to solve that. So let me clean up here. This would be 2xy prime plus y squared, and then minus x cubed y prime, and then minus again y, 3 y x squared. That should have been 3x squared y, but I'll leave it this way. And now we'll make it so that the y primes are together. So 2x y prime and negative x cubed y prime, and then equals, and I'll remove everything else. I'll start with a negative 3yx squared, but I'll make it positive 3x squared y. That's this right there. It moved to the other side, and we have, what else? Minus y squared. That's this term moved over. We had 1, 2, 3, 4 terms. 1, 2, 3, 4 terms. Okay, and the last thing is I'll factor out y prime and divide by its factor. But I think we can do it all in one step. So I'll just say y prime equals 3x squared y minus y squared all over 2xy minus x cubed. And it's factoring out y prime, and so 2xy minus x cubed is what's left over, and you're going to be dividing out by that quantity. This stays exactly the same. So there's your derivative. What do you do now? You have 2 points, 1, 3, and 1, negative 2. So for each one of those points of tangency, you're going to have 2 different tangent lines, and you're going to have 2 different slopes. So take the point 1, 3, plug it in, get an answer, and then take the point 1, negative 2, plug it in, get an answer. And then you'll have a point and a slope for each one, and then you can do the point slope equation for each one of those. So I went ahead and plugged in the values, and I got that the slope is 0 when I plug in 1, 3 into the slope equation, and I get that the slope is 2 when I plug in 1, negative 2 into the same slope equation. So remember, 2 tangent lines. I'm just going to write the equation of the tangent line for the point 1, negative 2. You can do the rest. And so it's just going to be y equals m, which is 2, times x minus 1, plus k, which is negative 2. Or that should just be minus 2. And you don't have to simplify that. You know, what the heck, let's just do the other. The other would be y equals the slope 0 times x minus 1. But now the y is 3, so plus 3. And in essence, that's just y equal to 3, because the 0 slope doesn't change a thing. So it's actually a horizontal line. This ends up being a horizontal tangent. And this is 2x minus 2 minus 2. That's 2x minus 4 for the other line. So we answered the question. We found the tangent lines at those 2 points where the x-coordinate was 1. Now, part B, they want us to find the x-coordinate of each point on the curve where the tangent line is vertical. And let's just remember what that means. If you have a vertical line, that means the slope is undefined. So we'll go with that. If the slope is undefined, then I take a look at the slope, which is y prime right over here. And to set that equal to undefined means we have to take the denominator and set it equal to 0. Okay? Now, what if it had said the tangent line is horizontal? If it's horizontal, then the slope has to be 0 And the only way for the fraction to be 0 would be to take the numerator and set it equal to 0. But this one is vertical, so the denominator has to be 0 to make the fraction undefined. The denominator is 2xy minus x cubed, and we're going to set that equal to 0. How do we solve this equation? Remember from class again, you should not be adding x cubed to both sides, because you add x cubed and the next thing you want to do is divide by x, and that's where you'll go wrong, because we can't divide by a variable because the variable could be 0 and we don't want to divide by 0. So the thing to do in these cases is always to factor out. I can factor out an x, and then I'll have 2y minus x squared, and that equal to 0. Okay, and then I'm going to take that and work with it some more. So by the zero factor property, either x is equal to 0 or 2y minus x squared is equal to 0. And I'm just setting each one of those two factors equal to 0. The first one gives me an answer already. It says that x must be 0. And see the question? Find the x coordinate of each point where the tangent line is vertical. So there's one point. But we need to figure out the other. So we need to solve this equation. And to do that, I can solve for y. It's easier to solve for y than it is to solve for x. So 2y is equal to x squared. And then y equals x squared over 2. But that doesn't give me any y values. So what I have to do now is go to the original equation and plug in y equal to x squared over 2 and figure out what the y value would be. So here's the original equation up here. I'm going to take this y, plug it in for every single y value, and try to get an answer for x. So that's going to look like x times y, so x squared over 2 squared, minus x cubed times y, which is x squared over 2. Let me fix this. And that equals 6. And that's going to be, let's see, x squared squared, that's x to the 4th, times another x, that's x to the 5th. This pencil doesn't work. X to the 5th over, and then that was 2 in the denominator, but it was being squared, so 2 squared is 4, minus, the second fraction is just x cubed times x squared, so it's also x to the 5th. And get x to the 5th over 2, and that is equal to 6. You have a fraction, two fractions. If you want to, you can multiply everything by 4, because it's the common denominator for 4 and 2. This is the fastest way to get rid of your fractions. I have a feeling I've done this problem before. And I don't mean last year, I think we did this in class. X to the 5th minus 2x to the 5th is equal to 24. That's just me distributing the 4. So negative x to the 5th is equal to 24. So x to the 5th is equal to negative 24. So x is equal to the fifth root of negative 24. Now, this is not an imaginary number because it's the fifth root of negative 24. And so that actually makes it okay. It's an odd root. Now, the problem here is it says to find the x-coordinate. There, you found two x-coordinates. So you're a happy camper, and then you box them in and move on. And then you find out a day later that this is wrong. There's nothing wrong with the last answer. This is actually okay. What you are supposed to do, anytime they say, you know, find us where the tangent line is vertical or horizontal, and they ask you to find points. They're looking for the points, or just the x-coordinate, or just the y-coordinate, but in essence, points. What you are supposed to do is, once you have a point, or what looks like is, you know, half a point, you are supposed to take that coordinate, plug it back into the original, and make sure that it makes sense. Make sure that when you plug in a 0 here, you get a y that makes sense. And the same thing for this. Make sure you plug it back in and make sure that there's a proper y value coming out of it. And so let's take, for instance, x equal to 0. What if I plug it into the original? Then I'll get that, let's see, that'll be 0 minus 0, because those y's are going to multiply as 0. So then for that, I just get that 0 is equal to 6, but that's not true. So what that means is that the slope wants to be undefined. Your slope wants to be undefined because that's how we found that x, by setting the denominator equal to 0. But then the function says, there's no point 0. There's no point on the curve where x is 0. So it's not, there is no tangent line, and so this x equal to 0, it's actually nonsense. But the only way you're going to figure that out is to plug into the original equation once you have found the x. Now the second one, I don't really have to plug in this value here. Why not? Because I did some extra work. See how I had to go back to the original here, and I plugged in the y value into the original. So this is already taking care of it. So then I know that whatever comes out of it has to be the right answer, because I used the original to get that value. Whereas this one was more direct. We just got it from taking the denominator equal to 0 from the derivative, but this never touched the original function. Again, it's a very important concept to spend a few minutes going over it. My only answer then is that x equals the fifth root of negative 24. It looks like we're gonna review more stuff in class tomorrow, so there won't be a test tomorrow. We'll delay it one day and pass it on if you want to. Thank you.